Have you ever stopped to think about that invisible force? You know, the one that snaps your fridge door shut or guides a ship across a huge, empty ocean? Well, today, we're going to uncover the secrets of magnets, a power that shapes our world in ways you might not even realize. So, our whole journey into magnetism actually starts with a bit of a creative challenge. This is Reshma, and she wants to write a really special story for her grandmother's 60th birthday. She's dreaming up this tale from way back in the day. A ship filled with spices, gets caught in just a terrifying storm. The waves are crashing, the sky is pitch black. I mean, no stars, no moon, absolutely nothing to guide the sailors. They are completely and utterly lost. And this left Reshma with a huge problem. How could her sailors possibly find their way in the middle of all that chaos and darkness? Seriously, how do you move forward when you have no idea which way is which? To figure out this dilemma for her sailors, Reshma started doing some research, and that's when she found it, the answer, a pretty remarkable device that's been guiding travelers for centuries. The solution was the magnetic compass. This simple little tool, it works day or night, rain or shine, even when you can't see the sun or the stars. But how? What's the secret that makes that little needle point so steadily? To really get how a compass works, we've got to get a handle on the force that powers it. Magnetism. And it all starts with what magnets are and what they stick to. Okay, first things first, let's talk about the stuff magnets actually grab onto. They're only attracted to very specific materials, like iron, nickel, and cobalt. We call these magnetic materials. So think paper clips, steel pins, or, the door of your fridge. But on the other hand, most things around us just aren't interested. Your wooden desk, a plastic ruler, a glass cup, a magnet will have zero effect on them. These are what we call non-magnetic materials. So we know what magnets stick to, but here's where it gets really, really interesting. A magnet's power isn't the same all over. It's incredibly strong, but only in two very specific spots. Look at this. This is amazing. When you sprinkle tiny little iron filings over a bar magnet, they don't just cover it evenly. Nope. Instead, they create these beautiful, arching patterns that get super dense right at the two ends. This is basically a visual map of the magnet's invisible force field. These ends are called the magnetic poles. Every single magnet, doesn't matter what shape or size it is, has two of them, a north pole and a south pole. And this is where the magnetic force is at its absolute strongest. And here is the key rule. You can never, ever separate them. It's impossible. If you take a magnet and break it, you don't get a separate north piece and a south piece. Instead, each new piece instantly becomes its own little magnet, or the brand new north and south pole. And these two poles, well, they interact based on one simple, unbreakable law that explains everything. The rule is so simple, but it governs everything. Opposites attract and likes repel. A north pole will always pull toward a south pole, but it'll push another north pole away. This one principle, it's the secret behind everything from a simple compass to those futuristic maglev trains that float on an invisible magnetic cushion. All right, now we have the key. Let's see how this simple rule of attraction and repulsion can save Reshma's sailors from that storm. So here's the biggest secret of all. If you let a magnet just swing freely, it's always going to point in the same direction, north-south. Why? Because our entire planet is a giant magnet. Yep, deep inside, its molten iron core is spinning, generating this massive magnetic field with its own north and south pole. And this idea is so fundamental, you can actually prove it yourself at home. All you have to do is magnetize a regular old sewing needle just by stroking it with a magnet. Once you float that magnetized needle, it's going to line itself up with the Earth's magnetic field and point north. Bam! You've just made a compass. So now that we kind of get the science, we can start having some real fun with this invisible force. But, like with any tool, you gotta be a little careful. You can use a magnet's power to do what looks like straight-up magic. You can guide things through a maze without even touching them, or make toy cars mysteriously push each other away. It's all just that law of poles in action. But magnets, well, they're also surprisingly delicate. They lose their strength if they get too hot, if they're dropped or hammered. You can almost think of it as the magnet's personal plea. Hey, handle with care. To keep them strong, magnets need to be stored the right way. Bar magnets, for example, are kept in pairs with their opposite poles lined up. Then, these little pieces of soft iron called keepers are placed across the ends.
This helps contain that magnetic field and keeps the magnets from getting weaker over time.
So, from guiding ancient sailors across stormy seas to just sticking a shopping list to your fridge, magnetism is this fundamental, invisible force that's just woven into the fabric of our world. We've explored the science behind Rishva's story, but the real question is, now that you know the secret, what will you discover with it?